In the deep darkness of the constellation Scorpius, a massive red star burns like a cosmic ember suspended in space. For thousands of years, people looked at this glowing light and gave it a powerful name: Antares, the rival of Mars. But Antares is far more than a bright star in the night sky. It is a red supergiant, a colossal star so large that if it replaced our Sun, its surface would stretch far beyond the orbit of Mars, swallowing the inner planets completely. And yet, this giant is slowly approaching the end of its life. One day, Antares will collapse and explode in a spectacular supernova, briefly shining brighter than almost anything in the sky. A final cosmic farewell from one of the largest stars we can see with the naked eye. Before we explore the mysteries of this dying giant, make sure to subscribe to Stellar Depth, where we journey deep into the universe and uncover the most fascinating secrets of space. Tonight, we explore Antares, the red heart of the Scorpion, finding the red heart in the night sky. Long before telescopes, satellites, and space probes, the night sky was the greatest map humanity possessed. Ancient civilizations looked upward not only for beauty, but for meaning, navigation, and stories that helped explain the universe around them. Among the thousands of stars scattered across the sky, a few always stood out, brighter, stranger, or more colorful than the rest. One of those stars was Antares. To the naked eye, Antares appears as a deep reddish point of light, glowing within the constellation Scorpius, the Scorpion. Even today, far from city lights, you can easily spot it during summer nights in the northern hemisphere. When Scorpius rises above the southern horizon, its curved tail and bright stars create the unmistakable shape of a giant celestial scorpion. Right at the heart of that shape sits Antares, glowing like a burning ember in the darkness. For ancient observers, that red color was impossible to ignore. Most stars appear white or faintly blue when seen from Earth, but Antares has a noticeably warm, orange-red glow. It flickers slightly as Earth's atmosphere distorts the light traveling across hundreds of light-years of space. Because of this color, many ancient civilizations associated the star with fire, blood, or the beating heart of the mythical scorpion. The Greeks gave it the name Antares, which means the rival of Ares. Ares was the Greek god of war, represented in the sky by the red planet Mars. When Mars passes through the constellation Scorpius, the two objects can look strikingly similar. Two bright red lights competing for attention in the same region of the sky. To early astronomers, it looked almost like a cosmic rivalry. But Antares had many names long before modern astronomy existed. In ancient Persia, it was known as one of the four royal stars, celestial guardians marking the seasons. In Arabic astronomy, it was called Qalb al-Aqrab, the heart of the scorpion. In Chinese star charts, it was part of a massive celestial dragon, marking the dragon's heart. Across cultures separated by thousands of kilometers and many centuries, one thing remained constant. People recognized Antares as something special. And they were right. A giant hidden behind a small point of light. When we look at Antares with our eyes alone, it appears no different from any other bright star. A tiny spark in the sky, but that tiny spark hides a truly staggering reality. Antares is not just large, It is immense beyond imagination. Modern measurements show that Antares is a red supergiant star, one of the largest types of stars known to exist. Its diameter is roughly 700 times larger than the Sun. To understand how enormous that is, we need to think about the scale of our own solar system. If Antares were placed where our Sun sits today, its surface would extend far beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and Mars entirely. Some estimates even suggest that its outer atmosphere might stretch close to the orbit of Jupiter. The Sun, which feels unimaginably huge to us, would appear almost microscopic compared to Antares. Yet despite this enormous size, Antares is not particularly dense. In fact, red supergiant stars are extremely diffuse. Their outer layers are expanded and thin, almost like a cosmic cloud. If you could somehow travel inside the atmosphere of Antares, the gas surrounding you might feel thinner than the air at the highest altitudes on Earth. But the star's enormous size means it still contains many times the mass of our Sun, typically estimated around 12 times solar mass. That mass, and the nuclear reactions happening deep inside the star, is what keeps Antares shining. A star that is already old. Every star in the universe follows a life cycle. Stars are born when enormous clouds of gas collapse under gravity. As the gas falls inward, pressure and temperature rise until nuclear fusion begins in the core. Hydrogen atoms fuse into helium, releasing energy that pushes outward and balances the crushing force of gravity. For millions or billions of years, this balance keeps the star stable. Our Sun is currently in this stage, known as the main sequence, and will remain there for roughly another 5 billion years. But Antares is far more massive than the Sun, and massive stars live much shorter lives. The reason is simple. Larger stars burn their fuel far more quickly. Their cores are hotter and more violent, causing nuclear reactions to occur at a much faster rate. While our Sun may live for around 10 billion years, Antares will likely survive for only 10 to 15 million years in total. That may sound like a long time, but on the cosmic scale it is extremely brief. In fact, by astronomical standards, Antares is already nearing the end of its life. Why Antares is red. One of the most striking features of Antares is its deep red color. This color tells astronomers something very important about the star's temperature. Stars come in many colors depending on how hot their surfaces are. Blue stars are extremely hot, often exceeding 20,000 degrees Celsius. White stars are moderately hot. Yellow stars, like our Sun, are cooler. Orange and red stars are the coolest. Antares has a surface temperature of roughly 3,500 degrees Celsius, much cooler than the Sun's surface temperature of about 5,500 degrees Celsius. But that cooler temperature doesn't mean Antares is weaker or dimmer. Because the star is so enormous, it emits an extraordinary amount of total energy. In fact, Antares shines with tens of thousands of times the luminosity of the Sun. Imagine replacing our Sun with Antares. The sky would be filled with a giant, glowing red sphere, stretching across much of the horizon. Even though its surface is cooler, the star's massive size would flood the entire solar system with energy. Yet the red color also reveals something else. It tells us that the star has expanded dramatically. Red supergiants are stars that have already consumed most of their hydrogen fuel in the core. As the core contracts and heats up, the outer layers expand outward into an enormous, bloated envelope. This expansion causes the surface temperature to drop, giving the star its reddish glow. In other words, Antares looks red because it has entered the final evolutionary stages of stellar life. A star surrounded by dust and gas. Unlike many stars that appear as isolated points of light, Antares is surrounded by a vast envelope of gas and dust. Astronomers have observed enormous plumes of material being ejected from the star's outer layers. These plumes stretch billions of kilometers into space, forming a chaotic, constantly changing environment around the star. This happens because the outer layers of red supergiants are unstable. The star's surface constantly expands, contracts, and erupts with massive convection cells, gigantic bubbles of hot gas rising and falling across the surface. These cells can be so large that each one could be larger than the entire orbit of Earth. Sometimes these turbulent motions push huge amounts of material away from the star, creating clouds of dust that drift through space. Over time, this expelled material will become part of the interstellar medium, the vast reservoir of gas and dust from which new stars and planets will eventually form. In this way, stars like Antares help recycle matter throughout the galaxy. The iron in our blood, the oxygen we breathe, and the carbon in every living organism all originated in the hearts of ancient stars like this one. Antares, in its final stages of life, is slowly returning its material back to the galaxy. A binary companion. For many years, astronomers believed Antares was a single star, but modern telescopes have revealed that Antares actually has a companion star orbiting nearby. This companion, known as Antares B, is a hot blue star, orbiting at a great distance from the red supergiant. While Antares A, the red giant, dominates the system visually, Antares B is actually much hotter and shines with a blue-white light. However, because the red supergiant is so bright and enormous, the smaller star is difficult to observe. The contrast between the two stars is dramatic. One is a cool, bloated, aging red supergiant nearing the end of its life. The other is a hot, young blue star burning intensely. Together, they create a fascinating stellar system where two very different stages of stellar evolution exist side by side. The distance to Antares. Despite how bright Antares appears in our sky, the star is incredibly far away. It lies roughly 550 light-years from Earth. That means the light entering your eyes tonight left Antares around the late 1400s, during the time when explorers were first crossing the Atlantic Ocean. Everything we see from that star is ancient light traveling across interstellar space. Even at this immense distance, Antares remains one of the brightest stars in the night sky. It ranks among the top 20 brightest stars visible from Earth. This brightness is another clue to just how powerful the star truly is. If Antares were placed at the same distance as the nearest star, only a few light years away, it would dominate the sky with overwhelming brilliance. A cosmic giant, nearing its final act. When astronomers study Antares, they are not just studying a star. They are witnessing a brief and dramatic stage in stellar evolution. Red supergiants represent the final phase of life for massive stars before they explode in one of the most powerful events in the universe, a supernova. At the moment, Antares is slowly fusing heavier and heavier elements deep inside its core. The process will continue until the star eventually forms an iron core that can no longer produce energy through fusion. When that happens, gravity will suddenly win the battle that has been raging for millions of years. The core will collapse in a fraction of a second, and the outer layers of the star will explode outward in a catastrophic burst of energy. That explosion will briefly outshine entire galaxies. But that moment is still in the future. For now, Antares continues to glow quietly in the constellation of Scorpius, its red light traveling across hundreds of light years to reach us. A giant star, slowly aging, a cosmic heart beating in the darkness. And somewhere deep inside it, the countdown toward one of the universe's most spectacular events has already begun. The true scale of Antares. When we look up at the night sky, stars appear small and distant, like tiny points of light scattered across a dark canvas. Even the brightest stars look no bigger than a grain of sand held at arm's length. Our eyes cannot see their true size, only their light. Antares is a perfect example of this illusion. To the naked eye, Antares looks like just another bright star glowing in the constellation Scorpius. But in reality, the tiny red point you see hides one of the most enormous stars in our region of the Milky Way. Understanding the scale of Antares requires something we are not naturally good at imagining: astronomical size. Human minds evolved to understand mountains, oceans, and continents. Even the largest things on Earth are incredibly small compared to objects in space. When we try to picture a star hundreds of times larger than the Sun, our intuition quickly fails. But we can begin to understand it through comparison. The size of our Sun. Our Sun is already enormous. With a diameter of about 1.39 million kilometers, the Sun is large enough that more than 1 million Earths could fit inside it. If the Sun were hollow, you could theoretically place the Earth inside it over 1 million times, and still have space remaining. Even the largest planets in our solar system look tiny beside the Sun. Jupiter, the biggest planet, is about 10 times smaller in diameter than the Sun. For centuries, astronomers believed the Sun itself was an unimaginably huge object, perhaps one of the largest things in existence. But stars like Antares completely change that perspective. Antares compared to the Sun. Antares is roughly 700 times larger in diameter than the Sun. This means that if you placed Antares at the center of our solar system, replacing the Sun, the star's surface would extend far beyond the orbit of Mars. Mercury would disappear inside it. Venus would disappear inside it. Earth would disappear inside it. Mars would disappear inside it. Even the asteroid belt between Mars and Jupiter would likely be swallowed by its enormous atmosphere. In fact, the outer layers of Antares are so extended and diffuse that they might reach close to Jupiter's orbit, depending on how the star expands and contracts over time. Imagine standing on Earth and looking up at the sky if Antares replaced our Sun. Instead of a small, bright disk half a degree wide, the sky would be dominated by a massive red sphere stretching across the heavens. The entire horizon could glow with the dim crimson light of the star's enormous surface. Day and night would disappear. The sky would be filled with a constant red twilight. But even this comparison barely captures the scale. Because Antares is not just large, it is also constantly changing, a star that breathes red supergiant. Stars like Antares are unstable. Their outer layers behave almost like a slow cosmic breathing motion. The star expands, contracts, and releases massive plumes of gas into space. Astronomers studying Antares have discovered that its size can change significantly over time. The star's atmosphere is not a sharp boundary like the surface of a planet. Instead, it gradually fades outward into space, forming an extended envelope of gas and dust. This means the true diameter of Antares is difficult to measure precisely. Different observations sometimes produce slightly different values, because astronomers are essentially measuring different layers of the star's enormous atmosphere. But regardless of the exact measurement, one thing is certain. Antares is one of the largest stars visible to the naked eye from Earth, the surface of a red supergiant. The surface of a star like Antares would look nothing like the surface of the Sun. Our Sun's surface is covered in granules, small convection cells, roughly the size of Texas. Hot gas rises, cools, and sinks again, creating a constantly boiling appearance. But Antares operates on a much larger scale. Instead of millions of small convection cells, red supergiants may have only a few gigantic ones covering their entire surface. Each of these cells could be so large that it spans a region bigger than the entire orbit of Earth. These enormous bubbles of gas slowly rise and fall over months or years, creating huge bright and dark patches across the star's surface. If you could observe Antares up close, its surface would appear turbulent and chaotic, a slowly shifting landscape of glowing plasma rising and collapsing across vast distances. In some areas, gas erupts outward into space, forming massive arcs and plumes that extend far beyond the star itself. These eruptions help explain why Antares is surrounded by clouds of gas and dust drifting away into the surrounding interstellar medium. How bright is Antares? Although Antares is cooler than the Sun, its enormous size allows it to produce a tremendous amount of light. Astronomers estimate that Antares shines with about 60,000 times the luminosity of the Sun. If you replaced the Sun with Antares, Earth would not simply warm slightly. It would likely become completely uninhabitable. Even though the star's surface is cooler, the sheer amount of energy pouring from its massive surface area would overwhelm our planet. However, because Antares is more than 500 light-years away, its immense brightness is reduced by distance. By the time its light reaches Earth, it appears as just a bright star among many. Distance hides its true power. The distance problem. Astronomers measure distances in space using a unit called the light year. A light year is the distance light travels in 1 year, roughly 9.46 trillion kilometers. Antares lies approximately 550 light-years from Earth. That means the light we see from Antares tonight began its journey sometime in the 15th century, long before modern science existed. While the light traveled across space, civilizations on Earth rose and fell. Entire generations lived and disappeared before that same light finally reached our planet. In other words, when we observe Antares, we are seeing the star as it existed centuries ago. And because massive stars evolve quickly, the Antares we see today may not be exactly the same as the star that exists there right now. In extreme cases, astronomers sometimes discover that a distant star has already exploded before the light of that explosion reaches Earth. For Antares, this possibility is extremely small, but the idea highlights the strange relationship between time and distance in astronomy. Looking at the night sky is always looking into the past. Mapping the giant. For most of human history, stars were impossible to measure directly. Even powerful telescopes could only show them as tiny points of light. But modern astronomy has developed techniques that allow scientists to directly measure the sizes of distant stars. One of the most important tools is called interferometry. Instead of using a single telescope, astronomers combine the light from multiple telescopes separated by large distances. This effectively creates a telescope the size of the distance between them. Using interferometry, astronomers have been able to resolve the actual disk of Antares, seeing it not as a point of light, but as a faint, glowing sphere. These observations have even revealed details of the star's turbulent atmosphere and the massive plumes of gas escaping into space. For the first time in history, humans have begun to map the surfaces of distant stars, and Antares has become one of the most fascinating targets for these observations. The slow loss of a giant. One of the most important processes happening inside Antares right now is mass loss. Red supergiants lose enormous amounts of material into space as they approach the end of their lives. Powerful stellar winds carry gas away from the star at speeds of tens of kilometers per second. Over thousands of years, these winds can remove huge portions of the star's outer layers. In the case of Antares, astronomers have observed massive clouds of gas expanding outward into space, forming a complex environment around the star. This surrounding material plays an important role in the star's future. When Antares eventually explodes as a supernova, the shock wave from the explosion will collide with these surrounding gas clouds, creating spectacular structures and intense bursts of radiation. But long before that final explosion, the star is already shaping its cosmic environment. Every year, Antares sends more material drifting into the galaxy. The life cycle of massive stars. Antares belongs to a class of stars known as massive stars. These stars begin their lives with many times the mass of our Sun. Because of this mass, their cores become extremely hot and dense, allowing them to fuse heavier elements much more quickly. The life cycle of a massive star is dramatically different from that of a smaller star like the Sun. After exhausting hydrogen in the core, the star begins fusing helium into heavier elements such as carbon and oxygen. Later stages may involve fusion of neon, silicon, and other elements. Each stage occurs faster than the previous one. While hydrogen fusion can last millions of years, later stages may last only thousands or even days. Eventually, the star forms an iron core. Iron is a special element in stellar physics because it cannot release energy through fusion. Instead, fusing iron actually consumes energy. When a star's core becomes mostly iron, the delicate balance between gravity and outward pressure breaks down. Gravity suddenly wins. The core collapses, and the star explodes. But that story belongs to the final chapter of Antares' life. For now, the red giant continues its slow evolution, burning heavier elements in its core while its outer layers drift gently into space. The giant in the Scorpion. Every summer, observers in the northern hemisphere can watch Antares rise above the southern horizon. It shines steadily, glowing with a warm reddish color among the stars of Scorpius. To casual observers, it may look like just another bright star. But now we know the truth. That small red point of light is a colossal stellar giant. A star hundreds of times larger than the Sun. A star powerful enough to swallow entire planets. A star slowly approaching the final act of its life. And somewhere deep within its enormous core, nuclear reactions continue to forge the elements that will one day be scattered across the galaxy. Antares is not just a star. It is a reminder of the immense forces shaping the universe and of the dramatic fate awaiting the most massive stars in the cosmos. And as we continue our journey into the story of this red supergiant, we will begin to explore the violent processes happening deep inside its core. The processes that will eventually lead to one of the most spectacular explosions the universe can produce. Inside the heart of a dying giant, far beneath the glowing red surface of Antares lies a region no telescope will ever see directly, the core of the star. Hidden under layers of gas hundreds of millions of kilometers thick, this central furnace is where the true story of Antares unfolds. From the outside, the star looks calm, a steady red light in the night sky, a distant giant quietly shining in the constellation of Scorpius. But inside Antares, the environment is unimaginably violent. Temperatures reach hundreds of millions of degrees. Pressures crush matter into states far beyond anything found on Earth, and nuclear reactions constantly transform one element into another. The core of Antares is not stable in the way our Sun's core is. It is changing. And those changes are signs that the star is approaching the final stages of its life. The balance that keeps stars alive. Every star in the universe survives because of a delicate balance between two opposing forces. The first force is gravity. Gravity pulls all the matter in the star inward, trying to collapse the star toward its center. The more massive the star, the stronger this inward pull becomes. Opposing gravity is the second force, energy from nuclear fusion. Inside the core, atomic nuclei are smashed together under extreme pressure and temperature. These fusion reactions release enormous amounts of energy, which pushes outward. As long as these two forces remain balanced, gravity pulling inward and fusion pushing outward, the star remains stable. This balance is known as hydrostatic equilibrium. For stars like our Sun, this balance can last billions of years. But for massive stars like Antares, the story unfolds much faster. When hydrogen runs out, during most of a star's life, it fuses hydrogen into helium in its core. Hydrogen is the most abundant element in the universe and serves as the primary fuel for stars. In the Sun, this hydrogen-burning stage lasts billions of years. But Antares was born far more massive than the Sun, and massive stars consumed their fuel much more quickly. Within only a few million years, the hydrogen in the core of Antares was exhausted. At that moment, the balance inside the star changed dramatically. Without hydrogen fusion producing energy in the center, gravity began to pull the core inward. The core contracted and heated up, while the outer layers expanded outward. This expansion is what transformed Antares into a red supergiant. The star grew hundreds of times larger, its outer atmosphere cooling, and turning the deep red color we see today. But the story did not end there. Helium fusion begins. As the core contracted under gravity, temperatures eventually climbed high enough for a new type of fusion to begin. Instead of hydrogen, the star began fusing helium atoms together. 3 helium nuclei combine in a process known as the triple alpha reaction, forming carbon. Some of that carbon can then fuse with helium to create oxygen. These reactions produce tremendous energy, temporarily restoring the balance between gravity and pressure. For a while, the star stabilizes again, but helium fusion does not last nearly as long as hydrogen fusion. The helium in the core is gradually consumed, and once again, the star faces a new crisis, a chain reaction of fusion. Massive stars like Antares do something extraordinary. As each fuel source runs out, the core contracts again, raising the temperature even higher. This allows new types of fusion reactions to begin. Over time, the star starts fusing heavier and heavier elements. Carbon begins fusing into neon and magnesium. Neon fusion produces oxygen and magnesium. Oxygen fusion creates silicon and sulfur. Silicon fusion eventually produces iron. Each stage happens faster than the previous one. Hydrogen fusion can last millions of years. Helium fusion may last hundreds of thousands of years. Carbon fusion may last only a few hundred years. The final stages of fusion inside massive stars can occur over astonishingly short timescales, sometimes days or even hours. Inside Antares, this chain of nuclear reactions is building a complex internal structure, the onion structure of a massive star. If we could somehow slice Antares open and look inside, we would see something remarkable. The star would resemble a giant cosmic onion. Each layer of the star would contain a different fusion reaction. At the center lies the iron core. Surrounding it is a shell where silicon fusion occurs. Outside, that is a layer where oxygen fusion takes place. Beyond that lies a layer where carbon fusion occurs. Farther out, helium fusion continues in another shell. And finally, in the outer regions of the star, hydrogen fusion still takes place in thin layers. Each layer is producing energy, feeding heat and pressure outward into the star's enormous atmosphere. This layered structure is one of the defining features of massive stars nearing the end of their lives. It also signals that the final act is approaching. The problem with iron. All the fusion reactions inside stars release energy up to a certain point. That point is iron. Iron is special because it has one of the most stable atomic nuclei in nature. Fusing lighter elements into iron releases energy. But attempting to fuse iron into heavier elements requires energy instead of producing it. This means that once the core of a massive star becomes mostly iron, the star can no longer generate the outward pressure needed to resist gravity. At that moment, the entire balance holding the star up begins to collapse. The collapse of the core. When the iron core grows too massive, gravity suddenly overwhelms the star's internal pressure. The core collapses inward at an incredible speed. Within a fraction of a second, the core can shrink from the size of Earth to a sphere only about 20 kilometers across. The density becomes so extreme that protons and electrons are forced together to form neutrons. This process creates an incredibly dense object known as a neutron star. But the collapse of the core is only the beginning. When the core suddenly stops collapsing, it sends a powerful shockwave racing outward through the star. This shockwave tears through the surrounding layers, blasting the star apart in one of the most violent explosions in the universe, a supernova. The future of Antares astronomers believe Antares is already well into the late stages of its life cycle. Its enormous size, unstable atmosphere, and heavy mass loss all indicate that the star is approaching the end of its evolution. But predicting exactly when the explosion will occur is extremely difficult. In astronomical terms, Antares could explode very soon, perhaps within the next 100,000 years. Or it could survive for several 100,000 years more. Either way, the event will happen long after our current civilizations have changed beyond recognition. Yet when the explosion finally occurs, it will be visible across the galaxy. From Earth, a supernova from Antares could shine as bright as the full moon, possibly even visible during the daytime. For weeks or months, the sky would contain a brilliant new star blazing in the constellation of Scorpius. Then, slowly, the light would fade, but the aftermath would remain for thousands of years. A stellar legacy. When Antares eventually explodes, it will scatter enormous quantities of newly created elements into space. These elements, oxygen, silicon, calcium, iron, and many others, will enrich the surrounding interstellar medium. Over time, those materials may collapse into new clouds of gas. From those clouds, new stars and planetary systems will form. Some of those planets may eventually host oceans, some may develop atmospheres, and perhaps, somewhere in the distant future, life itself may arise from the elements forged in the heart of Antares. In this way, the death of a star becomes the beginning of something new. Watching the red giant. For now, Antares continues to shine quietly in our night sky. Every year, during the warm months of summer, the constellation Scorpius rises above the horizon, and the red heart of the scorpion becomes visible once again. Most people see only a star, but now you know what truly lies behind that red glow. A colossal stellar giant. A furnace forging the elements of the universe. A dying star slowly approaching one of the most powerful explosions nature can produce. And in the next part of our journey, we will explore what happens when stars like Antares finally explode, and why those explosions are some of the most important events in the entire universe. The violent surface of Antares. From Earth, Antares looks calm, a quiet red star glowing in the night sky, steady and distant, shining softly among the stars of Scorpius. But appearances can be deceiving. In reality, the surface of Antares is one of the most violent and unstable environments in the universe. Beneath its calm red glow lies a turbulent sea of plasma constantly rising, collapsing, and erupting into space. Unlike planets, stars do not have solid surfaces. The surface we see is actually the photosphere, a thin layer where light escapes into space. Beneath that layer, the star is made entirely of hot gas, or more precisely, plasma, an electrically charged state of matter. And in a red supergiant like Antares, this plasma is in constant motion. The boiling surface of a giant star. Inside stars, heat generated by nuclear fusion deep in the core must eventually escape into space. One of the main ways this happens is through convection. Convection is the same process that causes water to circulate in a boiling pot. Hot material rises upward, cools as it reaches the surface, and then sinks back down to be reheated. On the Sun, convection creates millions of small bubbling cells across its surface. These cells, known as granules, are typically around 1,000 kilometers across. But Antares is not the Sun. Because the star is so enormous and its outer layers are so diffuse, convection operates on a dramatically larger scale. Instead of millions of small cells, Antares may have only a handful of gigantic convection cells covering its entire surface. Each of these cells could be so large that it spans a region larger than the orbit of Earth. Imagine a bubble of hot gas rising slowly across a region larger than our entire planet's orbit. That is the scale of motion happening on Antares. These enormous convection cells slowly rise, cool, and collapse over periods of months or even years, constantly reshaping the star's visible surface. If we could observe Antares up close, its surface would appear uneven and constantly shifting. Bright regions where hot gas is rising, darker regions where cooler gas is sinking back into the star. The star would look alive. Massive, stellar eruptions sometimes. The motion of these convection cells becomes so powerful that gas is violently ejected into space. These eruptions are far larger than anything seen on the Sun. When the Sun releases a burst of material, known as a coronal mass ejection, it can launch billions of tons of plasma into space. But the eruptions from Antares are on an entirely different scale. Observations have shown that Antares can eject enormous plumes of gas that extend billions of kilometers away from the star. Some of these plumes form long arcs or clouds drifting through space around the star. These clouds eventually cool and condense into dust, forming a faint envelope surrounding the red supergiant. Over thousands of years, this material slowly spreads outward into the surrounding region of space. This process is known as stellar mass loss, and it is one of the defining characteristics of red supergiant stars. Losing mass to the galaxy stars like Antares lose mass at astonishing rates. The star continuously releases gas into space through powerful stellar winds and eruptions. Astronomers estimate that Antares may be losing material at a rate of roughly 1/10,000th of the Sun's mass every year. That may not sound like much, but over thousands of years it becomes enormous. Eventually, the star will lose a significant portion of its outer layers before its final explosion. This expelled material plays an important role in shaping the star's future supernova. When the star eventually explodes, the blast wave will collide with these clouds of gas and dust, creating glowing shock waves that can remain visible for centuries. But even before that final moment, the material drifting away from Antares is already influencing the surrounding galaxy. The birthplace of future worlds, the gas and dust released by stars like Antares become part of the interstellar medium, the vast mixture of matter filling the space between stars. This material does not remain scattered forever. Over millions of years, gravity can cause these clouds to collapse again, forming new regions of star formation. From these collapsing clouds, new stars are born. Around some of those stars, planets will eventually form. The atoms inside those planets, oxygen, carbon, iron, silicon, were originally created in the cores of massive stars like Antares. In fact, nearly every element heavier than hydrogen and helium was forged inside stars. Some were produced during the quiet fusion processes inside stars. Others were created during the explosive violence of supernovae. This means that every rocky planet, every mountain, every ocean, and even every living organism is made from the recycled material of ancient stars. The atoms in your body were once part of stars that lived and died billions of years ago, and Antares is now contributing to that same cosmic cycle. Observing the atmosphere of Antares, for centuries, astronomers could only guess what the surfaces of stars looked like. Stars appeared as tiny points of light, even in the most powerful telescopes. But modern astronomy has developed technologies capable of revealing details that were once impossible to observe. Using instruments such as the Very Large Telescope Interferometer in Chile, astronomers have been able to study the atmosphere of Antares in remarkable detail. By combining the light from multiple telescopes spread across large distances, scientists can effectively create a telescope with an enormous virtual diameter. This technique allows astronomers to detect subtle variations in the light coming from different parts of the star. These observations have revealed that Antares has huge turbulent structures across its surface. They have also detected enormous clouds of gas extending far beyond the star itself. In some cases, these clouds stretch distances comparable to the entire size of our solar system. For the first time, humanity has begun to observe the dynamic atmosphere of a distant supergiant star. A star with an unstable atmosphere. One reason Antares loses so much material is that its outer atmosphere is only loosely bound by gravity. Although the star is extremely massive, its enormous size spreads that mass over a huge volume. This makes the outer layers of the star relatively fragile. When convection cells rise through the star's atmosphere, they can easily push gas outward beyond the star's gravitational grip. Radiation pressure from the star's intense light can also help push material away. Together, these forces slowly peel away the outer layers of the star. Over time, the star becomes surrounded by an expanding envelope of gas and dust. This envelope acts almost like a cosmic fog, drifting outward from the dying giant. The companion star Antares is not alone in space. It has a companion star known as Antares B, a smaller but much hotter blue-white star orbiting at a great distance. This companion star was first discovered in the 19th century, but it is extremely difficult to observe because the brilliant red glow of Antares overwhelms it. Antares B is thought to be a blue main sequence star, much hotter and younger than the red supergiant. While Antares has expanded into its final stage of life, the companion star is still in an earlier phase of stellar evolution. The contrast between the two stars is striking. One is an enormous red giant nearing the end of its life. The other is a hot, compact blue star, still burning hydrogen steadily in its core. Their relationship gives astronomers valuable clues about the formation and evolution of stellar systems. The red giant's final transformation. As Antares continues losing mass and burning heavier elements in its core, the star slowly moves closer to the final phase of its life. Over time, the iron core inside the star will grow larger and larger. When that core becomes too massive to support itself, gravity will trigger a catastrophic collapse. The entire star will explode. But before that moment arrives, Antares will continue its slow transformation. The surface will remain unstable, gas will continue drifting into space. And the red giant will keep shining quietly in the night sky, appearing peaceful from a distance, even as violent forces reshape it from within. A giant that shapes the galaxy. Stars like Antares are rare. Most stars in the universe are small, faint red dwarfs that will quietly burn for trillions of years. Massive stars, on the other hand, live fast and die violently. But despite their short lives, they play a crucial role in shaping the evolution of galaxies. Without massive stars, the universe would contain very few heavy elements. Planets like Earth might never have formed. Life as we know it might never have existed. The short life of a massive star ultimately helps create the conditions necessary for complex worlds and living organisms to emerge. And somewhere in the distant future, when Antares finally explodes, its final act will scatter enormous amounts of material across the surrounding region of the Milky Way. Material that may one day become part of new stars, new planets, and perhaps even new forms of life. But that dramatic ending is still ahead. For now, Antares continues to burn quietly in the sky, a massive, unstable giant, slowly preparing for the moment when it will unleash one of the most spectacular explosions the universe can produce. The supernova that awaits every star has an ending. Some stars fade slowly, cooling quietly over billions of years as they shrink into dim remnants drifting through space. Others collapse into exotic objects, like white dwarfs or neutron stars, their nuclear fires extinguished but their gravity still immense. But the most massive stars in the universe do not die quietly. They die in explosions so powerful that they briefly outshine entire galaxies. Antares belongs to this dramatic category. Somewhere in the distant future, whether tens of thousands of years from now or perhaps longer, the giant red star in the heart of Scorpius will reach the final moment of its life. And when that moment arrives, Antares will explode in a supernova. The final collapse, the story begins deep in the core of the star. For millions of years, Antares has been burning heavier and heavier elements inside its core. Hydrogen became helium. Helium became carbon and oxygen. Later stages created neon, magnesium, silicon, and finally iron. But iron is the end of the line. Unlike earlier fusion reactions, fusing iron does not release energy. Instead, it consumes energy. When the core becomes mostly iron, the star can no longer generate enough pressure to support itself against gravity. At that moment, the balance that has kept the star stable for millions of years suddenly breaks. Gravity wins. The iron core collapses inward with incredible speed. In less than a second, the core shrinks dramatically, compressing matter to densities greater than those found inside atomic nuclei. Electrons and protons are forced together to form neutrons, creating an incredibly dense object known as a neutron star. The collapse happens so violently that the inner core rebounds outward, creating a powerful shock wave. That shock wave begins racing through the star. The explosion of a giant. As the shock wave travels outward, it tears through the surrounding layers of the star. The immense pressure blasts the outer layers into space at speeds of tens of thousands of kilometers per second. This is the moment when the star becomes a supernova. For a short time, the dying star releases more energy than the sun will produce during its entire lifetime. The explosion sends an expanding cloud of gas into space. a glowing nebula filled with the elements created inside the star. This expanding debris will continue racing outward for thousands of years. But the light from the explosion will be visible for only a few weeks or months. During that brief time, Antares will transform from a distant red star into one of the brightest objects in the sky. What it would look like. From Earth, because Antares is roughly 550 light-years away, the supernova would not be dangerous for Earth. The explosion would release enormous energy, but the distance is far too great for it to cause significant harm to our planet. Instead, the event would be one of the most spectacular astronomical sights in human history. For several weeks, the star could shine as bright as the full moon, possibly even visible during the daytime sky. Imagine stepping outside at night and seeing a brilliant new star blazing in the constellation Scorpius, bright enough to cast faint shadows across the landscape. For generations of astronomers and skywatchers, it would be an unforgettable event. Ancient civilizations recorded several nearby supernova explosions in history. The most famous occurred in 1054 AD, when Chinese astronomers observed a brilliant new star appearing in the sky. That explosion created the Crab Nebula, which can still be seen today. Another supernova in 1604, observed by the astronomer Johannes Kepler, was bright enough to be visible in daylight. If Antares exploded today, it would likely rival those historic events. For a brief moment in cosmic time, the heart of the Scorpion would shine brighter than almost any star in the sky, the birth of a neutron star. After the explosion fades, something remarkable remains behind. The collapsed core of Antares will likely become a neutron star. A neutron star is one of the strangest objects in the universe. Although it contains roughly the mass of the Sun, it is compressed into a sphere only about 20 kilometers across. That means a teaspoon of neutron star material would weigh billions of tons. The gravity at the surface of a neutron star is so intense that escaping it would require traveling at a significant fraction of the speed of light. In some cases, neutron stars rotate extremely rapidly, spinning dozens or even hundreds of times per second. These rapidly spinning neutron stars emit beams of radiation from their magnetic poles, creating objects known as pulsars. Whether the remnant of Antares becomes a pulsar depends on several factors, including how fast the core is rotating when it collapses. But regardless of the exact outcome, the result will be one of the most extreme objects known in physics. The expanding supernova remnant, the outer layers of the star, blasted into space by the explosion, will continue expanding outward for thousands of years. This expanding cloud of gas and dust is known as a supernova remnant. Over time, the remnant will grow larger and more diffuse, interacting with the surrounding interstellar medium. Shock waves from the explosion will heat the gas to millions of degrees, causing it to glow in X-rays and visible light. Eventually, the remnant will become a complex nebula filled with filaments and glowing arcs. Inside those glowing clouds will be the elements created during the life and death of the star: oxygen, carbon, silicon, iron, and many other elements essential to the formation of planets and life. The death of a star enriches the galaxy with new material. The cosmic recycling process. Every supernova plays a role in the chemical evolution of the universe. The early universe contained almost nothing except hydrogen and helium. But inside stars, nuclear fusion created heavier elements. Supernova explosions then scattered those elements across the galaxy. Over time, this material mixed with interstellar gas clouds. When new stars formed from those clouds, they inherited the enriched elements produced by previous generations of stars. This process is known as stellar recycling. It is the reason planets like Earth exist. Without supernova explosions, the universe would contain almost no heavy elements, no rocky planets, no oceans, no life. Every atom of iron in your blood was once created inside a star. Every atom of oxygen you breathe was forged in stellar cores. In this way, the life and death of stars are directly connected to the existence of life itself. And when Antares eventually explodes, it will contribute to that same cosmic cycle. Could we predict the explosion? One of the biggest questions astronomers ask about massive stars is whether it is possible to predict when they will explode. Unfortunately, predicting supernova explosions is extremely difficult. Although scientists understand the overall life cycle of massive stars, the exact timing of the final collapse is uncertain. Antares shows several signs that it is approaching the final stages of its life. Its enormous size, unstable atmosphere, and rapid mass loss all indicate that the star is evolving quickly. But quickly in astronomy can still mean hundreds of thousands of years. From the perspective of human civilization, that is essentially forever. Still, astronomers continue to monitor stars like Antares carefully. Advanced telescopes and space observatories study their atmospheres, brightness variations, and surrounding gas clouds. Each observation helps scientists better understand the final stages of stellar evolution. And one day, somewhere in the universe, astronomers will witness a nearby star reaching its final moment. The quiet before the end for now. Antares continues shining in the constellation Scorpius. Its red light travels across hundreds of light-years of space before reaching Earth. To the casual observer, it is simply a beautiful star, glowing above the southern horizon on warm summer nights. But behind that calm glow lies a giant star approaching the final chapter of its life. Deep inside its core, nuclear reactions continue forging heavier elements. Its surface remains turbulent, sending clouds of gas drifting into space, and gravity is slowly preparing for the moment when the core will collapse. When that moment finally arrives, Antares will transform from a quiet red giant into one of the most powerful explosions the universe can produce. But until that distant day, the red heart of the Scorpion continues beating softly in the night sky, a reminder of the immense forces shaping the cosmos and of the dramatic fate awaiting even the most colossal stars. The cosmic neighborhood of Antares. When we look at Antares in the night sky, it appears as a single glowing point of red light. But in reality, this giant star is not alone. It exists within a rich and complex region of space filled with other stars, clouds of gas, and vast structures that stretch across the Milky Way. Antares sits inside one of the most recognizable constellations in the sky, Scorpius, the Scorpion. For thousands of years, people across many civilizations have seen the same shape in the stars: a long, curved body, a sharp tail, and a glowing red heart marking the center. That heart is Antares. But the constellation itself is not a physical object. The stars that appear to form the Scorpion are actually scattered across enormous distances in space. Some lie hundreds of light years away from Earth, while others are much closer or farther. Antares happens to lie about 550 light years from our planet, placing it within a fascinating region of the Milky Way known as the Scorpius-Centaurus stellar association, a region of massive stars. The Scorpius-Centaurus region is the nearest large stellar nursery to Earth. It is not a single cluster, but rather a loose association of young stars spread across hundreds of light years of space. These stars were born from the same giant molecular cloud millions of years ago. Many of them are massive stars, far larger and brighter than our Sun. Because massive stars live fast and die young, this region is constantly changing. Some stars are still forming, while others have already exploded as supernova, blasting shock waves through the surrounding clouds of gas. Antares itself likely formed in a similar environment many millions of years ago, when gravity caused a dense region of gas and dust to collapse into a newborn star. At that time, Antares was probably much hotter and brighter, a massive blue star burning hydrogen at an incredible rate. Over time, as the star consumed its fuel, it expanded and cooled, eventually becoming the red supergiant we see today. The companion star Antares is actually part of a binary star system. Orbiting the giant red supergiant is a smaller, but much hotter star known as Antares B. This companion star is a blue main sequence star, significantly smaller than Antares but much hotter on its surface. While Antares glows red at around 3,500 degrees Celsius, Antares B burns at temperatures exceeding 18,000 degrees Celsius, giving it a brilliant blue-white color. Despite its intense heat, Antares B is difficult to observe. The reason is simple. Antares itself is so enormous and bright that its red glow overwhelms the light from the companion star. For centuries, astronomers struggled to see Antares B clearly. Only with powerful telescopes and special observing techniques could the faint blue star be separated from the overwhelming glare of the red giant. The two stars orbit each other at a distance of roughly 550 astronomical units, more than 500 times the distance between Earth and the Sun. At that distance, a complete orbit may take thousands of years. From the perspective of Antares B, the red supergiant would dominate the sky like an enormous crimson sun, filling the heavens with a glowing red atmosphere, the Scorpion in the sky. The constellation Scorpius itself is one of the most striking star patterns visible from Earth. During summer nights in the northern hemisphere, Scorpius rises low in the southern sky, forming a curved chain of bright stars that resembles a giant scorpion. Antares marks the center of this celestial creature. Above it lies the curved body of the Scorpion, while below it, the stars sweep downward into a long tail ending in a sharp stinger. Because Scorpius lies along the Milky Way, the region is filled with rich star fields, nebulae, and clusters. Through binoculars or a small telescope, the area around Antares becomes crowded with hundreds of faint stars and glowing clouds of gas. It is one of the most beautiful regions of the night sky, the Rho-Ophiuchi cloud complex. Not far from Antares lies one of the most fascinating regions of interstellar space, the Rho-Ophiuchi cloud complex. This enormous dark nebula is a massive cloud of gas and dust where new stars are currently forming. Unlike bright nebulae that glow with ionized gas, the Rho-Ophiuchi complex appears mostly as dark patches blocking the light of background stars. These dark regions contain dense concentrations of cold molecular gas, the raw material from which new stars and planets will eventually form. Within the cloud, gravity slowly pulls gas together into dense knots. Over time, these knots collapse and heat up until nuclear fusion begins, igniting new stars. In this way, regions near Antares are constantly producing the next generation of stars. While Antares itself is nearing the end of its life, new stars are quietly being born nearby. The cycle of stellar birth and death continues across the galaxy. A star in the Milky Way Antares is not just part of Scorpius. It is also part of something far larger, our galaxy, the Milky Way. The Milky Way contains between 100 and 400 billion stars, spread across a disk about 100,000 light-years wide. Our solar system lies roughly halfway between the center of the galaxy and its outer edge. When we look toward the constellation Scorpius, we are looking toward the dense inner regions of the Milky Way, where stars are packed more closely together. That is why the sky in that direction appears rich with stars and nebulae. Some of the stars we see in Scorpius are only a few hundred light-years away. Others lie thousands of light-years deeper into the galaxy. Antares happens to sit relatively close to us compared to many other massive stars. At around 550 light-years away, it is practically a neighbor on the galactic scale. The fate of Antares B. When Antares eventually explodes as a supernova, its companion star will experience an extraordinary event. Although the distance between the two stars is large, the explosion will still dramatically affect the surrounding region. The shock wave from the supernova will race outward at thousands of kilometers per second, eventually reaching the orbit of Antares B. When it does, the blast may strip away some of the outer atmosphere of the companion star. Astronomers have observed similar events in other binary systems where one star explodes while the other survives. Antares B will likely survive the explosion, but its environment will change dramatically. The sky around it will suddenly fill with expanding clouds of glowing debris. The red supergiant that once dominated the system will vanish, leaving behind either a neutron star or possibly even a black hole. For Antares B, the universe will become a very different place. The changing sky of the future constellations appear permanent to us, but over long periods of time they slowly change. Stars move through the galaxy at different speeds and in different directions. This motion is known as proper motion, and over thousands or millions of years, it gradually reshapes the patterns we see in the sky. Antares itself is moving through space at about 20 kilometers per second relative to the Sun. Over thousands of years, that motion will slowly shift the position of the star within the constellation Scorpius. Eventually, the familiar shape of the scorpion will begin to distort. Millions of years from now, the constellation may no longer resemble a scorpion at all. But long before that happens, Antares itself will have disappeared. Its final explosion will remove the red heart of the scorpion from the sky. Future civilizations, if any exist at that time, will look at the constellation and see a different pattern. The bright red star that once defined the heart of the scorpion will be gone. a giant among neighbors. Despite its enormous size, Antares is just one star among billions in our galaxy. Yet, its presence reminds us how diverse the universe truly is. Some stars are small and faint, burning slowly for trillions of years. Others, like Antares, are massive giants that live fast and die spectacularly. Both types of stars play essential roles in the evolution of galaxies. Without massive stars, the universe would lack the heavy elements needed for planets and life. Without smaller stars, the universe would lack the long-lived stable environments where life might develop. Together, they form a cosmic ecosystem, a vast network of stellar birth, life, and death. The red heart still shines. For now, Antares continues to glow quietly in the sky. Its red light travels across hundreds of light years before reaching Earth, a distant signal from a giant star nearing the end of its life. Around it lie stellar nurseries where new stars are forming. Nearby stars move slowly through the galaxy, reshaping the constellations over time, and orbiting the giant itself is a hot blue companion star, witnessing the slow aging of its enormous neighbor. But the calm we see today will not last forever. In the next part of our journey, we will explore something even more extraordinary: how astronomers are studying stars like Antares in incredible detail, using modern telescopes to reveal structures and processes that were once completely invisible to humanity. Because even though Antares is hundreds of light years away, we are slowly learning to see the surface of distant stars. Astronomers study a giant star. For most of human history, stars were mysteries. Even the brightest stars appeared as nothing more than tiny points of light in the sky. Early telescopes revealed the moons of Jupiter, the rings of Saturn, and craters on the moon, but stars remained stubbornly unresolved. No matter how powerful the telescope became, a star still looked like a small, glowing dot. Antares was no exception. For centuries, astronomers knew it was bright, reddish, and located in the constellation Scorpius. But its true nature remained hidden. No one could see its surface, measure its size directly, or observe the turbulent atmosphere surrounding it. Everything we knew about stars came mostly from their light. And, surprisingly, light contains an enormous amount of information. Reading the light of stars. When astronomers study a star, they do not just measure how bright it is. They also analyze its light using a technique called spectroscopy. When starlight is passed through a prism or a special instrument called a spectrograph, it spreads out into a rainbow of colors known as a spectrum. Within that spectrum are dark lines where certain wavelengths of light are missing. These lines act like fingerprints. Each chemical element absorbs light at specific wavelengths. By identifying these lines, astronomers can determine which elements exist inside the star. Using spectroscopy, scientists discovered that Antares contains elements such as hydrogen, helium, carbon, oxygen, and iron. These observations confirmed that the star is undergoing complex nuclear processes deep inside its core. But spectroscopy can reveal even more. By measuring how the spectral lines shift over time, astronomers can detect motion inside the star's atmosphere. Gas moving toward us slightly shifts the light toward blue wavelengths, while gas moving away shifts it toward red. Through these tiny shifts, Scientists can track the turbulent motion of gas across the surface of Antares. In this way, even without seeing the surface directly, astronomers can study the behavior of the star's atmosphere. Measuring the size of Antares, one of the greatest challenges in astronomy, is measuring the actual size of distant stars. Most stars are simply too far away for their disks to be resolved by a single telescope. But astronomers developed a powerful technique called interferometry to overcome this problem. Instead of using one telescope, interferometry combines the light from multiple telescopes spread across large distances. By carefully analyzing the interference patterns created by the combined light, scientists can achieve the resolution of a telescope much larger than any single instrument. In essence, the separate telescopes act together as one giant virtual telescope. Using this technique, astronomers have been able to measure the diameter of Antares directly. For the first time, the star was not just a point of light. It appeared as a tiny glowing disk. Although the disk is still extremely small from our perspective, these measurements confirmed that Antares is indeed hundreds of times larger than the Sun. Mapping the surface of a star, modern interferometers have gone even further. With extremely precise instruments such as the Very Large Telescope Interferometer, VLTI, in Chile, astronomers have begun to create maps of the surface of Antares. These observations revealed something remarkable. The surface of Antares is not smooth. Instead, it contains enormous, bright and dark regions, likely caused by gigantic convection cells rising and falling through the star's atmosphere. These cells are vastly larger than those found on the Sun. Some of them may span hundreds of millions of kilometers across. The maps also show massive plumes of gas extending far away from the star. These plumes confirm that Antares is continuously losing material into space, forming a vast surrounding envelope of gas and dust. For the first time, astronomers could actually observe the weather of another star. Watching a star change, unlike planets, stars are not static objects. They change over time. Some stars brighten and dim in predictable cycles. Others vary irregularly due to internal processes or surface activity. Antares belongs to a class of stars known as semi-regular variable stars. This means its brightness changes slowly over time. The variations are not extreme, but they are noticeable when measured carefully with telescopes. These changes occur because the star's outer layers are constantly expanding and contracting. In some cases, enormous convection cells can temporarily increase the brightness of certain regions of the star's surface. At other times, clouds of dust expelled from the star may partially block its light, causing it to appear slightly dimmer. By studying these variations, astronomers learn more about the complex dynamics happening within the star's enormous atmosphere. Observing the stellar wind. Another key focus of modern astronomy is the stellar wind flowing outward from Antares. Stellar wind is a stream of charged particles constantly escaping from the star's atmosphere. While the Sun also produces a stellar wind, known as the solar wind. The wind from Antares is far stronger. Because the star's gravity is weaker at its enormous outer layers, gas can escape more easily into space. This wind carries huge amounts of material away from the star every year. Astronomers observe this process using radio telescopes and infrared instruments that can detect the faint glow of dust forming in the expelled gas. Over time, this material spreads into the surrounding region of space, gradually forming a vast cloud around the star. This expanding cloud may eventually interact with the shock wave from the star's future supernova. Seeing Antares in different wavelengths, human eyes can only see a small portion of the electromagnetic spectrum, visible light. But stars emit radiation across a wide range of wavelengths, including infrared, ultraviolet, X-rays, and radio waves. Modern telescopes allow astronomers to observe stars like Antares across these different wavelengths. Infrared observations reveal the cooler gas and dust surrounding the star. Ultraviolet observations help detect hotter regions of the atmosphere and the influence of the companion star. Radio telescopes track the motion of gas drifting away from the star into space. Each wavelength provides a different piece of the puzzle. By combining all these observations, astronomers can build a far more detailed picture of the star's structure and behavior. The role of space telescopes. Some of the most important observations of Antares come from space telescopes. Space-based observatories avoid the distortions caused by Earth's atmosphere, allowing them to capture sharper images and detect faint signals that would otherwise be lost. Telescopes, such as the Hubble Space Telescope, have observed the surrounding gas clouds around Antares, revealing complex structures in the star's extended atmosphere. Other space missions studying infrared light have detected the warm dust drifting away from the star. These observations confirm that Antares is actively shedding material as it approaches the final stages of its life, modeling the interior of the star. Even with modern technology, astronomers cannot see directly inside the core of Antares. Instead, they rely on computer simulations. These simulations model the physical processes happening inside massive stars, including nuclear fusion, convection, radiation transport, and gravitational collapse. By comparing these models with real observations, scientists can estimate the internal structure of the star. The models suggest that Antares currently has a core where heavier elements are being fused, surrounded by multiple shells where other fusion reactions continue. This layered structure is typical of massive stars nearing the end of their lives. As the star evolves further, these layers will change until the final collapse of the iron core triggers the supernova explosion. A window into stellar evolution. Stars like Antares are incredibly valuable to astronomers because they provide insight into the late stages of stellar evolution. Massive stars are relatively rare compared to smaller stars like the Sun, and their final stages occur quickly in astronomical terms. Observing Antares allows scientists to study processes that eventually lead to supernova explosions. These processes include mass loss, atmospheric instability, and the complex fusion reactions occurring deep inside the star. Each observation helps refine our understanding of how massive stars live and die. In this sense, Antares is not just a distant red star. It is a laboratory for studying some of the most extreme physics in the universe. The giant we can still watch. Despite all our advanced technology, Antares still holds many mysteries. Astronomers continue to observe the star with ever more powerful instruments, hoping to detect new details about its structure and behavior. Future telescopes may reveal even finer details of its turbulent atmosphere. Some scientists even hope that upcoming observatories could capture changes in the star that signal the approach of its final collapse. But for now, Antares continues to glow steadily in the sky. Its red light has traveled across centuries to reach us, and with every new observation, humanity learns a little more about the life of one of the most magnificent giants in our cosmic neighborhood. In the final part of our journey, we will step back and reflect on what Antares teaches us about the universe, and why the life and death of stars shape everything we see around us. The legacy of a dying giant. For thousands of years, Antares has watched silently over the night skies of Earth. Ancient civilizations saw it rise above the horizon and gave it names that reflected its fiery glow. To the Greeks, it was the rival of Mars. To Arabic astronomers, it was the heart of the Scorpion. To many cultures, it was simply a star that stood out, red, mysterious, and powerful. Yet, what those early observers could not know was that Antares is not merely a star shining quietly in the sky. It is a cosmic giant approaching the final act of its life. And when that final act eventually unfolds, it will reshape the surrounding region of the galaxy in ways that echo across millions of years. To understand the true significance of Antares, we must step back and look at the broader story of the universe, a story in which the life and death of stars play the central role. The universe was once simple. In the beginning, the universe was incredibly simple. Shortly after the Big Bang, the cosmos contained almost nothing but hydrogen and helium. These two elements made up nearly all of the matter that existed. There were no rocky planets, no metals, no oxygen to breathe, no carbon-based life. The first stars began forming hundreds of millions of years later, when gravity caused enormous clouds of hydrogen gas to collapse inward. Inside those newborn stars, nuclear fusion began transforming hydrogen into helium. Over time, heavier elements started to appear. But these early stars did not live forever. Many of them were massive stars, similar in size or even larger than Antares, and when they died, they exploded. The first supernova. The earliest supernova explosions were among the most important events in cosmic history. These explosions scattered newly created elements into space: carbon, oxygen, silicon, iron, and many others. Without those elements, the universe would still be a simple sea of hydrogen and helium. Instead, the explosions enriched the cosmos with the raw materials needed to form planets, oceans, atmospheres, and eventually life. Each generation of stars inherited the elements created by earlier generations. New stars formed from clouds that contained more and more heavy elements. Over billions of years, the chemical complexity of the universe increased, and somewhere within this evolving cosmic environment, our solar system eventually formed. The atoms within us. Every atom heavier than hydrogen inside your body was created inside a star. The oxygen you breathe was forged during nuclear fusion in stellar cores. The carbon in your cells formed inside ancient stars that lived long before the sun existed. The iron in your blood was created during the violent collapse of massive stars in supernova explosions. These atoms traveled through space for millions or billions of years before becoming part of the cloud that formed our solar system. Eventually, they became part of Earth, part of its oceans, mountains, and atmosphere, and ultimately, part of you. When we look at Antares, we are witnessing a stage of the same cosmic process that helped create the elements that make up our world. The death that creates new beginnings. The eventual supernova explosion of Antares will release enormous amounts of energy and material into space. The expanding cloud of debris will contain elements created during the star's lifetime: oxygen, magnesium, silicon, sulfur, calcium, iron, and many others. Over thousands of years, this material will mix with the surrounding interstellar medium. Shock waves from the explosion may even trigger the formation of new stars by compressing nearby clouds of gas. This process has been observed in many regions of the Milky Way. Supernova explosions often act as cosmic seeds, stimulating new bursts of star formation. In this way, the death of a star can lead directly to the birth of others. The universe continually recycles matter. Stars create elements. Supernovae scatter them. New stars and planets form from the enriched material, and the cycle continues, a brief life in cosmic time. Although Antares appears eternal to us, its life is actually quite short by cosmic standards. Our sun will live for about 10 billion years. Small red dwarf stars can survive for trillions of years. But massive stars like Antares burn through their fuel rapidly. Their entire life cycle may last only 10 to 15 million years. That means Antares has lived only a tiny fraction of the lifespan of the universe. It was born, grew into a massive blue star, expanded into a red supergiant, and will eventually explode, all within a relatively short cosmic moment. Yet despite its brief life, the star will leave behind a lasting legacy. The elements it created will travel across the galaxy, eventually becoming part of new stars, planets, and perhaps even life forms yet to exist. The sky as a story. When we look at the night sky, we often see it as something permanent. The stars appear fixed, their patterns unchanged from year to year. But the sky is actually a dynamic and evolving place. Stars are born in giant clouds of gas. They live for millions or billions of years. Then they die, sometimes quietly, sometimes violently. New stars replace them. Constellations slowly change shape as stars move through space. The sky we see today is only one moment in a vast cosmic timeline. In a million years, the patterns of stars will look different. In tens of millions of years, entire constellations will be unrecognizable. And somewhere in that distant future, the red glow of Antares will disappear from the sky. A future without the red heart. When Antares finally explodes, the familiar shape of Scorpius will change. The bright red star marking the heart of the scorpion will vanish. In its place may appear a faint expanding nebula, a glowing cloud of gas slowly drifting outward from the site of the explosion. At the center of that cloud may lie a neutron star, spinning rapidly and emitting pulses of radiation into space. Future astronomers, if any exist at that time, will study that remnant and learn about the star that once existed there. They may reconstruct its history. They may trace the elements within the nebula, and they may understand that long ago, the red heart of the scorpion exploded in one of the most powerful events in the universe. The quiet light we see today. But that future explosion has not yet happened. Tonight, Antares still shines in the sky. Its light continues traveling across space, reaching Earth centuries after it first left the star. For us, the red giant remains a distant beacon, a reminder of the immense scale and complexity of the universe. When you see Antares rising low in the southern sky during summer nights, you are looking at a star hundreds of times larger than the Sun. A star whose atmosphere stretches across distances greater than the orbit of Mars. A star nearing the end of its life. Yet from Earth it appears peaceful, a single red spark in the darkness. The lesson of Antares, the story of Antares, teaches us something profound about the universe. Stars are not just distant lights, they are engines of creation. They forge the elements that make planets and life possible. They shape the structure of galaxies. They transform the universe from a simple cloud of hydrogen into a cosmos filled with complexity. And even when they die, they do not truly disappear. Their material becomes part of new stars, new worlds, and new possibilities. In this sense, every star is part of a continuing cosmic story, a story that began billions of years ago and will continue long after our own sun has faded. Antares is simply one chapter in that story, but it is a spectacular one. A giant star glowing red in the constellation of Scorpius, a cosmic heart beating quietly in the darkness. And one day, far in the future, it will release its final burst of light. A supernova that will scatter the star's material across the galaxy. Until that moment arrives, Antares will continue shining in the night sky, reminding us that even the most distant stars are connected to the story of our own existence. Because in the end, we are all made from the ashes of stars. If Antares replaced our Sun. To truly understand how enormous Antares is, astronomers often use a powerful thought experiment. What would happen if Antares suddenly replaced our Sun? Of course, such a scenario could never occur in reality. Antares lies more than 550 light-years away, and stars cannot simply swap places in space. But imagining the consequences helps us grasp the true scale and power of this colossal star, and the results are astonishing. The solar system would disappear if Antares were placed at the center of our solar system. The first thing to realize is that the star's surface alone would engulf several planets. Mercury would vanish instantly. Venus would disappear deep inside the star's enormous atmosphere. Earth would not survive either. The orbit of our planet lies far inside the estimated radius of Antares. If the red supergiant replaced the Sun, Earth would be swallowed by the star itself, vaporized within the outer layers of hot gas. Mars would likely suffer the same fate. Some models even suggest that the outer atmosphere of Antares could extend close to the orbit of Jupiter. That means the inner solar system. Everything from Mercury to the asteroid belt would be completely gone. Instead of planets, there would only be a vast ocean of glowing plasma surrounding the giant star. A sky filled with red light. If Earth somehow existed just outside the surface of Antares, the sky would look nothing like the one we know today. Instead of seeing the Sun as a small bright disk, the entire sky would be dominated by an enormous glowing sphere. The star's surface would stretch across the heavens, filling the sky with deep red light. Day and night would no longer exist. The atmosphere of Earth would likely be stripped away by the intense radiation and stellar winds from the giant star. The surface temperature would climb to extreme levels, boiling away any oceans and melting the planet's crust. Within a very short time, Earth would become an unrecognizable world. The power of Antares Although Antares is cooler than the Sun on its surface, its immense size allows it to produce an extraordinary amount of energy. Astronomers estimate that Antares shines with tens of thousands of times the luminosity of the Sun. That energy spreads outward across space. If Earth were somehow placed at the same distance from Antares as it is from the Sun today, the planet would receive far more energy than it currently does. The intense radiation would make the planet completely uninhabitable. Even if Earth survived outside the star's atmosphere, the heat alone would sterilize the planet. But this scenario also reveals an important truth about stars. Size matters enormously. A star does not need to be extremely hot to produce tremendous amounts of energy if it is large enough, and Antares is one of the largest stars visible in our sky. The changing nature of the star. Another fascinating aspect of Antares is that it does not remain exactly the same size over time. Red supergiant stars often expand and contract slowly, like a breathing giant. Their outer layers rise and fall due to the enormous convection cells circulating inside the star. As a result, the star's radius can change over time. If Antares were placed in our solar system, the edge of the star might slowly move inward and outward, engulfing different regions of space as it expanded and contracted. This kind of stellar breathing happens over months or years. From a distance, astronomers can detect these changes through small variations in the star's brightness. But close to the star, the effect would be dramatic. Jupiter and the outer planets. If Antares replaced the Sun, the outer planets might survive, but their environments would change dramatically. Jupiter, Saturn, Uranus, and Neptune orbit far enough from the Sun that they might remain outside the star's enormous atmosphere. However, their skies would be dominated by the gigantic red disk of Antares. Instead of the Sun appearing as a small bright star in their skies, Antares would loom as a vast crimson globe, filling a large portion of the horizon. The planets would receive enormous amounts of radiation from the star. Their atmospheres would heat up, potentially changing their chemistry and weather patterns. The entire outer solar system would become a dramatically different environment. The future explosion. Eventually, the giant star would reach the final stage of its life. If Antares replaced the Sun and later exploded as a supernova, the consequences would be catastrophic. The explosion would release an unimaginable amount of energy. Within seconds, the shock wave from the supernova would sweep across the solar system. Any surviving planets would be bombarded by intense radiation and high-energy particles. Their atmospheres would likely be stripped away. The surfaces of the planets would be sterilized. The solar system, as we know it, would effectively cease to exist. Fortunately for Earth, Antares lies hundreds of light-years away, far beyond the distance where a supernova could cause such devastation. A useful perspective. Although this thought experiment may seem extreme, it provides a useful way to understand the scale of massive stars. When we look at Antares in the sky, it appears small and distant. But in reality, it is so enormous that it could swallow entire planetary systems. The contrast between what we see and what actually exists highlights one of the most fascinating aspects of astronomy. The universe is filled with objects far larger and more powerful than anything we experience on Earth. Yet because of the vast distances involved, they appear calm and tiny from our perspective. The fragility of planetary systems. Stars like Antares remind us how fragile planetary systems can be. The fate of planets depends heavily on the life cycle of their host star. Some stars remain stable for billions or even trillions of years, providing long-term environments where life might develop. Others evolve quickly and dramatically, expanding into giant stars or exploding in violent supernova. Massive stars rarely allow stable planetary systems to exist for long periods of time. Their intense radiation and short lifespans make them hostile environments for planets. But their deaths play a crucial role in enriching the galaxy with the elements needed for future worlds. The true scale of the universe. Thinking about Antares replacing the Sun also reminds us how vast the universe truly is. The Sun itself is enormous compared to Earth, yet the Sun is small compared to stars like Antares. And Antares, despite its gigantic size, is only one star among hundreds of billions in the Milky Way. Across the observable universe, there are trillions of galaxies, each containing billions or even trillions of stars. Some of those stars are even larger than Antares. Others are smaller and dimmer, quietly burning for trillions of years. The universe is filled with diversity far beyond what our everyday experience prepares us to imagine. A giant seen from afar. Fortunately for us, Antares remains safely distant. Its red glow continues to shine quietly in the constellation Scorpius, far beyond the reach of our solar system. From Earth, it appears as a single warm point of light, rising low in the southern sky during summer nights. Yet behind that small spark lies a star of immense scale and power, a star capable of engulfing planets, a star destined to explode in one of the most dramatic events in the universe, and a star that reminds us just how extraordinary the cosmos truly is. In the next part of our journey, we will explore something even more intriguing: how Antares compares with other giant stars in the universe, and why some stars grow even larger than this already colossal red supergiant. Giants among giants. Antares is enormous. A red supergiant hundreds of times larger than the Sun, powerful enough to swallow the inner planets of our solar system if it replaced our star. Its atmosphere stretches across distances that seem almost impossible to imagine, and its future supernova will one day release an explosion visible across the galaxy. But in the vast universe, even Antares is not the largest star known. Astronomy has revealed stars so immense that they make Antares appear almost modest in comparison. Understanding where Antares fits among these cosmic giants helps us appreciate both the incredible diversity of stars and the extreme limits of stellar physics. The family of red supergiants. Antares belongs to a class of stars known as red supergiants. These stars are among the largest and most luminous stars in the universe. They form when massive stars reach the late stages of their evolution and expand dramatically as their cores burn heavier elements. Red supergiants typically have radii hundreds of times larger than the Sun, and luminosities tens of thousands of times greater. Their surfaces are relatively cool compared to smaller stars, giving them their characteristic orange-red glow. Antares is one of the most famous members of this group. Another well-known example is Betelgeuse, the bright red star marking the shoulder of the constellation Orion. Betelgeuse is slightly larger than Antares and has become famous in recent years, because its brightness suddenly dropped in 2019, causing speculation that it might soon explode as a supernova. Although that dimming was eventually explained by dust clouds ejected from the star, the event reminded astronomers how unstable and unpredictable these massive stars can be. Even larger stars beyond Antares and Betelgeuse lie stars of truly staggering size. One of the most famous is UY Scuti, a red supergiant located roughly 9,500 light-years away in the constellation Scutum. UY Scuti is estimated to have a radius about 1,700 times larger than the Sun. If placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter, possibly even reaching the orbit of Saturn. Another enormous star is VY Canis Majoris, an unstable red hypergiant located in the constellation Canis Major. This star is surrounded by massive clouds of gas and dust produced by violent eruptions that have been ejecting material into space for thousands of years. Stars like these represent the extreme upper limits of stellar size. Compared to them, Antares is still enormous, but it is not the largest giant in the galaxy. The limits of stellar size. Why do some stars become so large? The answer lies in the delicate balance between gravity and radiation pressure inside stars. When massive stars begin exhausting their core fuel, their cores contract under gravity, while their outer layers expand outward dramatically. This expansion can inflate the star to enormous dimensions, creating a red supergiant. But there are limits to how large a star can grow. If a star expands too much, its outer layers become unstable and begin drifting away into space through powerful stellar winds. These winds gradually strip away the outer atmosphere of the star, preventing it from expanding indefinitely. Eventually, the star loses enough mass that its structure changes again, sometimes shrinking and heating up before its final collapse. Antares is currently in this unstable phase, shedding gas into space as it approaches the end of its life. The diversity of massive stars. Not all massive stars follow the same path as Antares. Some stars become blue supergiants, extremely hot stars that remain compact while shining with incredible brightness. Others evolve into Wolf-Rayet stars, rare objects that have lost most of their outer layers, exposing their hot cores directly to space. These stars produce powerful stellar winds and intense radiation that can shape the surrounding environment for thousands of light years. The exact path a star follows depends on many factors, including its mass, rotation, chemical composition, and interactions with nearby stars. Antares represents one of the possible final stages in this complex evolutionary process. A brief life for a giant. Massive stars live fast and die young. Compared to our Sun, which will shine steadily for around 10 billion years, stars like Antares burn through their nuclear fuel extremely quickly. Antares may have existed for only 10 to 12 million years since its birth. To put that into perspective, dinosaurs lived on Earth for more than 160 million years, far longer than the entire lifespan of many massive stars. Yet, despite their short lives, these stars have a profound impact on the universe. Their intense radiation shapes nearby clouds of gas. Their stellar winds sculpt the interstellar medium. And their final supernova explosions enrich the galaxy with heavy elements. Massive stars are the engines that drive the chemical evolution of galaxies. Watching the life cycle of stars, modern astronomy allows us to observe stars at every stage of their lives. In some regions of space, we can see giant molecular clouds where new stars are forming. In others, we observe stable stars like our Sun quietly burning hydrogen. Elsewhere, we see massive red supergiants like Antares nearing the end of their lives, and in still other places, we witness the glowing remnants of supernova explosions from stars that died thousands of years ago. By studying all these stages together, astronomers can piece together the complete life cycle of stars. Antares is a particularly important part of this story because it represents a star in the final stages before a supernova. Observing it helps scientists understand what happens inside massive stars shortly before they explode. A star, visible to the naked eye. One of the most remarkable things about Antares is that it is easily visible without any telescope. Anyone can step outside on a clear summer night and see the red heart of the Scorpion shining low in the southern sky. You do not need advanced instruments to witness this giant star. All you need is a dark sky and a clear view of the horizon. When you find Antares, you are looking at a star hundreds of times larger than the Sun, located hundreds of light years away. The light entering your eyes began its journey centuries ago. It traveled across the vast emptiness of space before reaching Earth tonight. In that sense, observing Antares is like looking back in time. The final light. One day, the light from Antares will change. At some moment in the distant future, the star will collapse and explode. The explosion will send a brilliant flash of light racing outward through the galaxy. Hundreds of years later, that light will finally reach Earth. When it does, people on our planet will see a new star suddenly appear in the sky. A brilliant point of light shining where Antares once stood. For weeks or months, the explosion will dominate the constellation of Scorpius. Then slowly, the brightness will fade. In the centuries that follow, telescopes will observe the expanding debris cloud left behind by the explosion. At the center may remain a neutron star, the dense, collapsed core of the once enormous giant. The meaning of Antares. The story of Antares is more than the story of a single star. It is a reminder of how the universe works. Stars are born from clouds of gas. They shine for millions or billions of years. They create the elements that form planets and life. And eventually, they die. But their deaths are not endings. They are transformations. The material from dying stars becomes the raw material for new stars, new planets, and new possibilities. In this way, the universe is constantly renewing itself. And Antares, the glowing red heart of the Scorpion, is one small but spectacular part of that endless cosmic cycle. Even now, as you read these words, the star continues shining quietly in the night sky. A distant giant, a dying sun, and a reminder that the universe is far more vast, dynamic, and beautiful than we can ever fully imagine.